Okay, guys, what I want to first do is give you the idea behind the square root property before telling you what the square root property is first, and then how we use it to solve some equations, okay? So let's just start with some basic information, some common knowledge. Let's say we all agree that positive 4 squared is 16. But if I were to take negative 4 and square it, negative 4 times negative 4 is also going to be positive 16. So combined, let's say I had some mystery number, x, and if I were to square that number and get 16, this tells me there's two possible answers to that. If a mystery number squared is positive 16, I know that that mystery number could be either positive 4 or negative 4. Okay? So this is the heart behind the square root property. Okay, square root property says if u squared, and I'm going to use u here to represent anything, okay? Maybe it's a value or a variable or an expression, but here's the inspirational message for the day. U can be anything. If u squared, if something squared equals, and I'm going to say d, and let's just think of d as being a constant for simplicity. It's just some sort of number. So if something squared equals a number, then the squared thing u could equal either the positive or the negative square root of that number. Okay, just like the positive square root of 16 is 4 and the negative square root of 16 is negative 4. That's what the square root property says. So we can use this property to help us solve some types of equations. So let's say my directions say solve. And my problem is x squared plus 36 equals 0. So it's a quadratic equation. It's in standard form. It equals 0 on one side. But if we tried factoring this, we would find out that x squared plus 36 just doesn't factor. All right? But if I solve for the squared thing, if I got the squared thing by itself by subtracting the 36 over, then x squared equals negative 36. And now I have something squared equals a number. So if something squared equals a number, I'm going to invoke this square root property and say that the squared thing, in this case x, this is my squared thing, is going to equal either the positive or the negative square root of that number. So x can equal either the positive or the negative square root of that number. And then I just simplify my square root. So I have plus or minus. The square root of negative 36 simplifies to, well, the square root of the 36 is a 6, but the square root of that negative, or negative 1, is that imaginary number I. So my two solutions are x equals positive 6i or negative 6i. So if I'm being real fancy and write this as a solution set, my solution set would be 6i and negative 6i. Okay? So let's do this again. Suppose this time, let's solve. Always read our directions. Suppose this time I want to solve 3x minus 2 squared equals, let's make up a number. Let's say, 20. feel like we always use 20. That's kind of boring. But I was struggling to come up with a funner number. All right. Now, I'm not going to write it out to prove it, but this is actually also a quadratic equation. It's just not written in standard form. So let's acknowledge first, why is it a quadratic? Imagine I actually squared all of this out. I'd have 3x minus 2 times another 3x minus 2. This 3x times the other 3x would get me like 9x squared, and then some other smaller things. And so it is a quadratic equation, but it would take quite a bit of work to get this in standard form. So square root property here saves us a lot of work because how is this thing written? This says something squared equals a number. So what I can do is I can use the square root property to basically get rid of this squaring and therefore get rid of these parentheses. Those parentheses would become unnecessary. So I can more easily solve for x. So something squared equals 20. So that means the squared thing, 3x minus 2, equals plus or minus the square root of 20. So let's take a moment and let's try to simplify the right side as much as possible. So we recall that 20 is not a perfect square, but if I think of this as the square root of 4 times the square root of 5, 4 is a perfect square. And so 3x minus 2 equals plus or minus, bring that down. The square root of 4 simplifies to just regular old 2 times the square root of 5 stuck inside the radical. Because it's not a perfect square, nor does it have any perfect square factors. Okay. So we've simplified the right side as much as possible, but eyes on the prize, we're supposed to solve for x. So ignore the right. I know the right looks scary, but it is focus on the left. If I had 3x minus 2 equals something, and we were to solve for x, then we would naturally add the 2 off. So if I'm going to add 2 to the left side, I have to add 2 to the right side. But in these cases where I have pluses or minuses involved especially, I'm going to take that plus 2 and I'm going to stick it in front of my plus or minus. Otherwise, you may inadvertently lead yourself to believe that some things are positive or negative that aren't. Okay, so that 2 on the right side is always going to be a positive 2. So 3x equals positive 2 plus or minus 2 square roots of 5. Okay, let's pause here. No, let's go ahead and finish solving for x. So at the moment, this x is being multiplied by that 3. So to get rid of multiplication of 3, we're going to divide both sides by 3. And then we get x equals positive 2 plus or minus 2 square roots of 5 divided by 3. And up front, I'm going to acknowledge that that is pretty much as simplified as I can make that. Big reasons why. If I'm dividing by 3, I can only really cleanly divide by 3 if my outside numbers here and here are also both divisible by 3, and they're not. 2 is not divisible by 3, so as a fraction, this can't be simplified. Second of all, let's talk about what this plus or minus means and why we as mathematicians are often lazy and just leave it like this. Let's consider what would happen if I were to split this up and write this as the plus in one expression and the minus in the other expression. What would happen? If I had 2 plus, that's terrible. Let me try that again. Plus 2 square roots of 5 divided by 3. We don't have to worry about the 3, but think about this right here. This does not simplify because these are, we say, not like radical terms. I can't call this 2 plus 2 4 because order of operations say I'm supposed to do this multiplication before I can do this addition. So this isn't the same as 4 square roots of 5. This is 2 square roots of 5, which is, going to be, I don't know, some 4-point something number, if I were to approximate it. And that 4-point something number plus 2 would be like 6-point something or another, which is a very different number than 2 plus 2 is 4. 4 times the square root of 5 would be like a 10-point something number, okay? Different than the 6-point something number that is correct, okay? So because this has a square root of 5, this term has a square root of 5, and this one doesn't, we say they're not like radical terms, and they can't really be combined or simplified in any meaningful sort of way. So we would just leave it as 2 plus 2 square roots of 5, all divided by 3. So that would be one of my solutions. And then the other solution would be 2 minus 2 square roots of 5 divided by 3. Again, if I'm being fancy and writing this in a solution set, I get this. Okay? Let me do one more example. And I'm going to do this example twice. So the first time we're going to do it, we're going to use the square root property. Okay, and it's going to be a quadratic equation. And let's say it is 3x squared minus 75 equals 0. So it's a quadratic equation, and it's in standard form. All right, so one of the reasons why I like square root property for this particular problem is, let me get my pointer, is we've got x squared, but we don't have any regular x's. If I had plus 75x or minus 75x, then I wouldn't use square root property. But since I just have x squareds and no regular x's, but then some constant terms, this is a great problem for doing square root property. But that means I've got to get the squared thing by itself. This has to say something squared equals a number. So, as you might expect, I'm going to add that 75 off first. Get my pen. Add 75. Add 75. And 75's cancel, leaving me with 3x squared on the left equals positive 75 on the right. Now, if I'm not careful, I may think, ooh, I'm ready for square root property, but I'm not. Because this currently does not say something squared equals a number. When I write this 3x squared, the only thing that's being squared is the x. Order of operations say I do the exponent before I do the multiplication. So I'm not squaring the 3, I'm only squaring the x. So to get the squared thing by itself, I've got to get rid of this multiplication as well. So I'm going to divide both sides by that 3. Multiplication and division cancel. So x squared equals 75 divided by 3 is 25. Now something squared equals a number. So now I can use the positive or the negative square root. I can think of that as getting rid of the squaring. So x equals plus or minus the square root of 25. And the square root of 25 does simplify. It is a perfect square. So I get x equals plus or minus 5, which means my solution set is 5 and negative 5. Okay? So that's how I can solve it using square root property. But I could also solve this problem using factoring. And I'm going to leave it to you to decide which one was easier. So let's start with 3x squared minus 75 equals 0. It is a quadratic equation. It is in standard form. It does equal 0 on one side. So if I'm going to try solving this by factoring, I always look for a greatest common factor first. And it turns out that both 3x squared and 75 are divisible by 3. So I'm going to pull that 3 out front. And when I take 3x squared divided by 3, that leaves me with the x squared. Minus 75 divided by 3 is 25. That equals 0. And then if I sort of acknowledge that this is multiplication here, when I multiply by just a constant, I can divide by that constant. Divide by 3 on both sides. And 3 divided by 3 cancels to 1, leaving x squared minus 25 on the left. Equals 0 divided by 3 is still 0 on the right. Then I keep factoring. X squared minus 25, that's a difference of two perfect squares. So that's going to almost automatically factor as x times x gets me my x squared. I'm going to need 1 plus and 1 minus. And then 5 times 5 is my 25. If I were to re-multiply that all out, I'd see the middle terms cancel out. Well, let me point to it. Positive 5x's minus 5x's cancel out to 0, leaving the x squareds and the minus 25. Okay, so having factored it completely, zero factor theorem says I can now set each factor equal to 0. So either x plus 5 equals 0 or x minus 5 equals 0. So solve each of those for x, and I get x equals negative 5 here, or x equals positive 5 here. Same thing I said right here. My two solutions are positive 5 or negative 5. My two solutions are positive 5 or negative 5. Okay, two good ways to work this problem. And one last sort of comment about square root property that I really should have said somewhere way early in the beginning, because this is one of my big pet peeves. If I use a square root to more or less get rid of squaring, I do have to consider both the positive and the negative root. There's going to be two solutions to this equation, okay? If I throw away the plus and the minus and I only do the square root, then I've thrown away half my answers. And if I've thrown away half my answers, I can't expect to get anything more than half credit, okay? So if I go from squaring, if I use a square root to get rid of squaring, I better have that plus or minus in there somewhere.